Hello everyone, welcome back. In this video, we're going to talk about dynamic arrays. We will also see how to implement our own dynamic array. So basically, a dynamic array, also known as a resizable array or array with a resizable capacity. With dynamic arrays, we can add or remove items at the runtime, and the array size grows or shrinks accordingly. Something we cannot do with normal arrays or static fixed size arrays. We learned in the previous videos a lot about static or fixed size arrays. We learned that arrays are fixed size and they are also called static data structures. Once we define the size of array, say I have defined an array of size 7. So this 7 is going to be fixed and we cannot grow or shrink the size of the 7. I have entered 5 numbers in this array, so I'm going to say size of array is 5 since I have entered only 5 numbers. So the capacity is 7. So I can enter 2 more numbers in this array, but once the array is full, I will not be able to enter more numbers. So either I can enter a number at the end of the array, say I want to enter number 6 at index 5, or if I want to insert a number at a given index or a desired index, say I want to insert number 20 at index 2, we learned so that we can start to insert a number at a given index, we can start traversing from end of the array. Say once I entered number 6, so my size will be increased. Now size is 6 and size is pointing here for end of array. Let's call it size for end of array. So end of array is pointing here. What I can do is I start traversing from end of array going all the way to the index location to where I want to insert the new item. Each time I traverse, I shift each element to the right. So 6 is going to be shifted here, and 5 is going to be shifted here, 4 is going to be shifted here, and 3 is going to be shifted here. So this way I can, once I reach the index location, I can replace this 3 with the new item, which is 20. Right now my array is full and I'm not able to insert more items. Once I inserted 20, so I'm gonna increase my size by 1, so size is going to be 7. Once capacity equal to size, this means we are at the capacity and we cannot enter more items to our array. Our array is full. Why we cannot enter more arrays to a full array? We can definitely replace an item if you want. So I say I want to replace number 1 with the number 100. I can do it easily, but I will lose number 1 from my collection. The reason why we cannot enter a new item to a full array is because, as we said, array items are stored in contiguous blocks of memory. In order to increase the size of this array or add a new item, I need to uh, append some contiguous memory locations at the end of this array. Say I want to add one more item at the end of this array, I have to append it in a contiguous block of memory. So I need to take memory 128. So the memory manager or compiler cannot guarantee whether this memory location is free or no. This memory location may be already filled with other data, so we cannot guarantee to get this memory location. That is why once we define the array size and all contiguous blocks of memory are allocated, we cannot shrink that or we cannot expand or grow the memory location. Also, we learned that once we give our array a name, so contiguous blocks of memory depending on the size of our data we store in our collection will be allocated, and the address of the first block of memory will be stored in array name. Using this address of the first block, we can access each other element. Say I want to access item at index 6, so using the sixth block, or I say array of 6, I can easily access the element. So how it works behind the scene, it's going to take the address of the first element, which is 100, the index value we want to access, in this case 6, 100 plus 6 into size of the data type we have stored in our collection. In this case, we have stored integers. An integer takes 4 bytes, so 6 into 4 is going to be 24. So the memory address of item at index 6 is going to be 24. So the compiler using this memory address can easily access an element from collection. So the accessing an element, the time complexity for accessing an element is big O of 1 or constant time. So no matter how much ever big the size of data is, we can access each element at big O of 1 or constant time complexity. So no matter this, if this is size of our data, so we can access each element at big O of 1 or constant time complexity. Same way, if we wanted to delete an item, say I want to delete number 3 from my collection. So what I can do this time, I copy each element to the left. So 4 comes here, then 5 comes here. Say I want to copy from index 2. So I keep traversing from index 2 to end of the array. Each time I traverse, I shift each element to the left this time. So 6 comes here. We have 6 here. Once we deleted an item, we are going to size was previously here, pointing to the end of array. So we decrement the size. Now size is pointing here. And we have this item or this element or this memory block unused. It's going to be there. We cannot release this memory and we cannot shrink the size of the array. So that's why arrays are not good for memory efficiency. Say I want to define an array of size 100 at the runtime. Say this is index 999 and the size is 100, and I only store 5 numbers in my array up to index 4. So the rest of 95 locations, memory locations assigned to this array will be wasted. We cannot release this memory location, or if we don't use it, so this will be wasted. Same way with when we delete an item from a full array, the memory locations that are not used, we cannot release them. So what if we want to add items at a full array? What we can do is we can grow our array using the grow method. We can add another element to an existing array. So what we are going to do, we'll create a new array of at least like 2 times of the new array. Say I have an array of size 5. It goes all the way from index 0 to 4. So I have created a bigger array. So what I can do is I can copy elements of the old array to the new array. Then I can add my new item. Say I want to insert 6, 7. Then at the end, what I can do is I will copy the reference of the new array to the old array. So I will let array or ARR point to the new array. So this way we can grow our old array and add new items to that. So the same way we can shrink the capacity of our array. Say we have a bigger array and we keep deleting from an array. When we implement our own dynamic array, so if we have a lot of unused memory blocks in our array, what we can do is we can shrink our array into half, and we can release these memory locations that we don't use. So searching an item for a value in an array, we learned that is going to take a linear time or big O of n time complexity. It has a big O of n time complexity, because we start when we search for an item. Say I want to search for item 10, if that is present in my array or no. 4, 5, 6, 7, 8, 9. So what I can do is I can start looping from the beginning of the array going all the way up to end of array. Either we find the array while looping, we find the item while looping, or we don't find that. So in most cases, in this case, if we don't find number 10, we have to loop through end of the array. So in most cases, the time complexity for searching an array is going to be a big O of n, or linear time complexity. As much as our data set grows, so the time taken to find an item grows as well. So that's why it is a linear time complexity to search for an item in a given array. So now let's see the implementation of details of dynamic arrays can vary depending on programming language or framework we are using. In most languages, dynamic arrays are built-in data structures, such as in Python we have list as a dynamic array. In a list data structure, we can add as many items as we want, or as many items we want to remove. Accordingly, the size of the list will grow or shrink. In Java, in case of Java programming language, we have array list, which is the implementation of a dynamic array. In JavaScript, we have arrays. In most lower level languages like C or C++, The dynamic arrays can be implemented using pointers and manual memory management. Although we have vectors in C++, but we can also implement our own dynamic array using pointers and manual memory management. In case of C Sharp, dynamic arrays are represented by the list class that comes from system.collection, the generic namespace. So this class provides a resizable array-like data structure that can grow or shrink dynamically uh, as elements are added or removed. So let me show you the built-in dynamic data structure, array data structure in C Sharp. As I said, it's called list. The class name is list. It's a generic class. So inside this brackets, we are going to provide the type of the values we store in our this dynamic array. So say we want to store integer types. So then we are going to give a name to our dynamic array. Say I want to give it dynamic array or DA equal to new list of ends. So this way we can use or leverage the built-in dynamic array in C Sharp. As I said, in Java it's called array list, in Python it's called list, or in JavaScript it's called arrays. In C++ we have vectors, which represents the implementation of dynamic arrays that grows or shrinks accordingly. Say I want to add so I didn't define the size of this dynamic array, so it has a default capacity. Once we reach the default capacity, it will grow automatically. So I want to add an item, so I can use the object name. Then using the dot notation, I can use the functions it provides. One of the function is add, so we can add as many items as we want. Say I want to add one. To print the items of the dynamic array or list, we can use a for each loop or for loop. So say I want to use for each var x in DA. I just want to print that. Say I want to print x. So if I run here, I can see one is printed. I have one element in my array. So say I want to add more elements, I can do that easily. I want to add 2, 3, 4, or 5. If I run that, so all the 5 elements are going to be printed. Same like static arrays, we can also access each element of a dynamic array or list using their index location by subscripting that. So say I want to access element at index 3, so I can use the object name, then I can subscript it and provide the index location. Say I want to access item at index 3. So let's run that. We can see an item at index 3 is 4. This way we can also modify elements at an index of the built-in dynamic array. Say I want to modify element at index 2, then I want to set it to 100. So I can do that. If I print my array, so at item at index 2 is 100 now. So this way we can use or leverage the built-in dynamic array. The next useful method they can provide is the remove method. Say I want to remove remove of, say I want to remove number 4. We can remove an item. Once we remove an item, so the size of the array grows or shrinks accordingly. We can print the size of the array list also. So in a nutshell, a dynamic array are abstract data types that provide the ability to resize storage capacity as needed. Unlike static arrays, which have fixed size that is determined at the declaration time, dynamic arrays can grow or shrink at the runtime. So in this video, we are not going to use the built-in dynamic arrays. We will try to build our own dynamic array using the static array or fixed size array we learned in the previous videos. So the dynamic array is implemented basically by allocating a block of memory that can hold a certain number of elements. So to define our own dynamic array, I'm going to delete these lines of code. We are going to build our own data type. Say I want to call it, we will create a class. I want to call it my dynamic array. So in this class, I will use the static array to hold the information. So first I'm going to define an array of integer type. Say we want to only store integer values in our dynamic array. So I'm going to use a private int array. So I'm going to only declare it here but not initialize it. Then I need to declare an integer value capacity showing the capacity of my array capacity. Then I'm going to define an integer variable int size showing the size of my array or how many elements I have stored in my array. Then let's inside the constructor of the class, let's initialize this value. So public my dynamic array. Once we create the object of this array, this constructor will be called. So I'm going to set the capacity, say the default capacity I want to be 5. So this dot capacity equal to 5. So initially we want to um, initialize our array as 5 blocks of memory. Once we reach 5 numbers, then we can grow that. So to initialize the array, so I can use this dot array equal to new array of this dot capacity and this dot size equal to 0. Initially the size of array is going to be 0. So let's define an overloaded constructor as well. If the user want to enter their own capacity instead of 5, but 5 is going to be the default capacity. But what if the user want to enter their own capacity? So we can define an overloaded constructor for that. Let's define another constructor that takes capacity in capacity. So instead of initializing the capacity to 5, this time we initialize it to the capacity the user passes. So I'm going to define another function here to show if the array is empty. So public it returns a boolean type. Boolean is empty. So it's going to return if size is equal to 0. If size is equal to 0, it's going to return true. Otherwise, it will return false. So let's create an object of this my dynamic array here, and let's test these functions. So I'm going to say my dynamic array da equal to new my dynamic array. So here I'm going to use some to print some information. So capacity I'm gonna use \t for tab, then plus da dot get capacity. Same way I'm gonna use print the size. So size da dot get size. Also, let's print if whether the array is empty or not. So is empty \t da dot get that is empty. So if I run my program, so the size is 0, is empty is true, since we haven't entered any value right now. So if we wanted to define a different capacity, say I want to define an array, and static a dynamic array of capacity 10. So it shows the capacity is 10, size is 0, and it's empty. So let's define a function to add values to my dynamic array. So public void add. This is going to take a value, and let's call it item. So first we are going to check if the array is full. So we check if size equal to this dot capacity. So what we are going to say, let's call it this dot size equal to this dot capacity. We are going to call a function grow that we are going to define it later on. Else we will add the element at the end of the array. So we say array of size equal to item, then we increment the size of array by 1. So let's very quickly define a grow function. Public void grow. That's not gonna do anything right now. So let's add some items to my array. So da dot add Say I want to add 1. So da dot add, say I want to add 2. So the capacity is 10 and the size is 2 and the is empty is false. So I defined some other functions here. One function is public void print. It's going to print all the items we have entered in our array. So it loops from the beginning of the array going to all the way to the size, how many elements we have entered, and it simply prints each element and separated by a white space. Then we have print all items function. This is going to loop through from the beginning of the array up to the capacity of the array. It's going to print all the elements. So once we initialize our array saying new int of this capacity, so when this initialization initially initialize each element of the array to the 0, so if we haven't entered any item to our array, so it's going to print all zeros going all the way up to capacity. Then I have overridden the toString method of C#. So basically, toString method returns the object representation of or represents our object in the form of a string, so that we can easily print the name of our object. So what is going to do, I have defined an empty string. I look through all the elements of the array and I append each element to our string separated by white space. Then at the end I add a square bracket at the beginning of the string and also at the end of the string to represent it as an array, and I return the string or str. Here I have printed the capacity, the size that is empty, and also since we have implemented or overridden the toString method, we can directly pass or print the object name. Then I have called the print function to print only the items, and also I have called the print all items to print all the items. So let's run our program. So we can see the size is, the capacity is 10. We have entered 2 elements, so the size is 2, is empty, is false. So this is our array having 1, 2. We have a white space here, we can remove that. So items we have entered 1, 2. All array or all array up to capacity is 1, 2 is entered going all the way up to 10. The rest of the elements are initialized to 0. So to remove this white space from here, so what we can do inside this function, before we add the ending a square bracket, we can call the trim function here to trim end function to trim all the white spaces from the end of the array. If I run it here, so this white space is gone. So let's set the capacity back to its default capacity. So I'm not going to pass any value in the constructor. So if I run that, we can see so that the capacity is 5 and we have 5 elements. Cool. Say I want to add 5 elements in my array, 1, 2, 3, 4, and let's add 5 here. So my array is full right now, and we should not be able to add more elements. So array is full, capacity is 5. Um, size is 5 and we have 5 elements. So if I wanted to add one more item, say I want to add 6, we shouldn't be able to do that. Array goes out of index out of the bound exception we get. So next we are going to define a grow function. Once so we are going to call the grow function. So basically the grow function is going to create a new array of a bigger capacity, then copy the elements of the old array to the new array, then finally update the reference of the old array to the new array. So what I'm going to do first, I'm going to increase the capacity. Say I want once every time we reach the capacity, I'm going to increase the capacity by 2. So what I can do is say capacity equal to capacity into 2. We can define as much as we want. So say if I want to increment the capacity by 10 each time, so I can say capacity plus 10 or capacity plus 5, whatever we want. So in this video I'm going to double the capacity each time we reach the capacity. So then I'm going to define a new array and array new array equal to new int of the capacity. So this is the capacity is 2 times right now. It's going to create a bigger array. So next, then using a for loop, I can copy each element of the old array to the new array. So for int I equal to 0, I less than size, or we less than size, I plus plus, we can use the capacity, not the capacity, the size, since we have increased the capacity. So array, new array of I equal to old array of I. Okay, so next we are going to update the reference of the old array to the new array. We can simply say array equal to new a, or new array, let's call it arr, new arr. So we have updated the reference of the old array to the new array, but this time when we add the sixth item, so our array should grow. We can see that right now the capacity is 10, previously it was 5. So we have the size of elements, the size of array is 6. We have 1 2 3 6, and we have the capacity, or all the arrays, we have entered 6 items, and the rest of the 4 items are initialized to 0. So this way we can grow the size of array dynamically. So now let's add more functionalities to our dynamic array. So say the add function adds each element at the end of the array, dynamic array. What if user wanted to insert an item at index location? Say a user want to add an item at index 2. So what we could do to insert an item at index, say I want to insert 20 here. What I can do is I start from looping from end of array going down. Each time I loop, I shift each element to the right. So let's do that, and let's define a function to our object. So I'm going to define a function after add public void. This function doesn't return anything. Let's call it insert at index. So this is going to take an item to insert at a given index. Then it's going to accept an index location. Before doing anything, we are going to validate the index value, whether it's a valid index value or not. If the user enters negative numbers, the index values that are less than 0, that's not going to be a valid index value. Or if the user enters an index value that's greater or equal to the size, that's not also a valid index value. So before that, we should validate the index value. If index value less than 0, or if index is greater or equal to the size, this is an invalid index value. So we are going to throw an index out of bound exception or out of range exception. Throw a new index out of range exception. Then if index is okay, then again we are going to check if our array is full. If it is full, we are going to grow or increase the capacity of the array. So if size is greater or equal to the capacity, we are going to call the grow function. Else we will insert the item at the given location by shifting each element to the right. So for that, I'm going to use a for loop for int I equal to size minus 1, I greater or equal to index location. We are going to come down up to index, and then I minus minus. Every time we loop, we are going to shift each element to the right. So I say array of I plus 1 equal to array of I. Then once I reach the index location, is going to get out of the loop. So what we can do is we can insert at the given index location. So what I can do is array of index equal to item. Then I will increase the size by 1. So let us insert da.insert at index. So I want to insert item 20 at index location 0. So let's do that. Okay, 20 is inserted at 0, and the size is increased by 1. 0 1 0 1 20 1 2 3 4 5 6. Cool. Let's insert 40 at index 2. So index 0, 1, 2. 40 is inserted at index 2 and size is increased by 1. Okay, 21, 42. Okay, cool. This way we can insert at a given location. So what if we wanted to get an item from an index location? So let's add another function, public. This is going to return an integer, get item at index. So this is going to take an index value. Before doing anything, again, we are going to check if index is out of range. So if so, we are going to throw an exception. Otherwise, we are going to just return index item at index location. So return array of index. That's it. So let's, before doing that, let's say I want to insert at index 20. So it should throw an exception saying index was out of bound. What if I wanted to insert an item at index -2? This is not also a valid index. So it says index out of bound exception. Cool. Index 4. So say I want to get an item from index 5. So da dot get item at a given index. So I'm gonna get an item at index 4. I can do that. So 40 is at index 4. Next, we are going to add the search functionality to our dynamic array. So the user should be able to search for a value. Let's delete that one. Here I'm going to add another function, public int. It's going to return the item if found, otherwise it will return a -1. Let's call it search int item. The user passes an item if the item is found. So this function is going to return the index value of that item, otherwise it will return a -1, means that the item was not found. So we are going to loop through each element of the array for int I equal to 0 and size I plus plus. So here I check if array of I equal to, if array of I equal to item, then return the index value, otherwise return -1. So say I want to search da dot search. Say I want to search 5. So I'm gonna get the index value of 5. So 5 is located at index 6. So say if I want to search for 50, it returns -1. 50 was not found in the array. So next we are going to define a function remove at given index. Say the user want to remove an item from this index, so the user should be able to do that. To remove an item, we saw that we are going to insert start looping from the index location going all the way up to end of the array. Then each time we loop, we shift each element, this time to the left. And also once we deleted the array, we decrement the size by 1, size minus minus. So this way we can delete an item from a given index location. So say I want to define a function here, public. This is going to return nothing, void remove item from index. This is going to take an index value. So before that, we are going to check if index is a valid index. If index is not a valid index, we are going to throw an exception. Then we will start looping from the index location going up to all the way up to size -1 for int I equal to index I less than size -1 I plus plus. Then we are going to shift each element to the left. So array of I this time is going to be equal to array of I plus 1. So here we say array of I plus 1. That's why we have to go to up to size -1. Otherwise, it's going to throw an exception out of range. So once we shifted each element, we are going to decrement the size by 1. Let me delete all these elements. So say I want to delete and add the item at index 1, so I can delete that. So if I call the da.remove item from index, was that, yeah, this I want to delete one item at index 1. Okay, 2 is gone and the size is decremented. We have 1 3 up to 6, 1 3 up to 6. Cool. So this way we can delete an item from an index location. Say if the item if the user want to delete an item instead of giving the index, say the user want to delete number 6 or number 5 or number 4, we can do that. We can define another function for that that takes an item. So public void remove item that takes an item, say int item. What we are going to do, we will loop through the elements of the array. If we found the item, what we are going to do is we are going to call the remove at index location. So let's do that for int I equal to 0, I less than size I plus plus. If array of I equal to item, that what we can do is we found the item to be deleted at index I, so we can easily call our function remove at index or remove from index, remove from index of I. So then we can break the loop or return. So let's say I want to da dot remove item, say I want to remove 5 or 4, so I should be able to do that. So 1 2 3 4 is gone and size is 5. So let's remove one more item, say I want to remove number 1. So size is 4, 1 is gone, capacity is 10. So this way we can remove an item from a given dynamic array. I think we are all done. We only can implement a shrink function when we remove all the elements. So say I want to remove 2 also, I want to remove 3 also. This way we have removed a lot of items from our arrays. See, the capacity is 10. So each time we remove that, we can, as we can see, all the elements are 6. We can reassign them back to 0. So we can see that we have only 2 items in our array, but the capacity is still 10. But we don't want that. Once we remove and reach a threshold, we want to shrink the elements of the array. Before implementing the shrink function, let's set these values back to 0 once we remove them. So to do that, I'm gonna go to remove from index function, and here I'm going to set array of size equal to 0 each time. So since in the remove item function we call this one, it's going to set to 0, but in case of a string or other tabs, we can set it to null or whatever we want. So in this case I'm going to set it to 0. So cool, we have 2 items, sizes, capacity is 10. So next let's go to shrink method. Shrink is going to be same as grow method. So what we are going to do is let's copy this grow method and paste it here. I'm gonna call it shrink. So shrink capacity, this time we are going to say if capacity equal to capacity divided by 2. So we are going to shrink the item, the size or the capacity of the array by 2. So each time we remove, before decrementing the size, we are going to check if the size is less than or equal to a threshold. Then we call the shrink method. So here we do size minus minus. Once we did size minus minus, we are going to check if size is less than or equal to, say, capacity by 3 or capacity by 4, let's say once if the capacity is under the third of the capacity, we're going to call the shrink method. Shrink method. Okay. Shrink public void shrink. So if I run my program, we can see that we have only two elements here. The size shrink to back to 5. So if I remove some of these items here, we still by having four elements in our uh, array of capacity 10, we have not reached the threshold, means that the size is not under the third of the capacity, so our array has not shrinked. So if I remove one more item, say I want to remove da dot remove item, say I want to remove 6, so this way if we reach the threshold, yes, we did, our array shrink back to 5. So this way we can implement our own dynamic array. Thank you guys for watching. Please don't forget to subscribe and see you in the next video. Bye bye.